Hello everyone, can you by any chance hear me? I had to leave the meeting just to make sure that I restart my mic. I'm not sure, can you guys hear me? Yeah, guys, I'm not too sure what really happening. If you guys can hear me and see my screen, can you please confirm so we can move forward, because I'm not getting any feedback on my side. All right. I guess we can start. In case there's any problem with the sound, guys, please let me know, because I'm not sure if I'm really audible, because I'm not getting the transcript of the.
I can hear you.
Oh, you can hear me. Okay. Thank you very much. Thank you for the feedback. All right, guys. Yesterday we spoke about different key machine learning methods, which we're going to continue today. We spoke about gradient descent. So the gradient descent, just to repeat, remember what I said yesterday, that when we're training the machine, we're going to have an error, which we're going to call the loss, which will be the difference between what we're trying to obtain and what we are actually doing with our machine. So now the gradient descent methods is a method that is used as a formula to try and reduce that error. And the reason why it's called a gradient descent method is because it uses what we call the negative gradient direction to search for different parameters. So which parameter are we looking for? The W, which is the weight. Okay. So the parameter called the weight needs to be reduced in order for us to reduce the loss. Okay, so this is the formula of the gradient descent. So the gradient descent is going to be changing the values of the weight every time it goes through the data until it can get and reduce the loss that we've accumulated when training our machine. Okay, so we have three types of gradient descent. We have the batch gradient descent, we have the stochastic gradient descent, and then we have the mini batch gradient descent. So the batch gradient descent means that every time we're going to take all the samples in our data, we're going to change the weight at the same time, and then we process. But the stochastic gradient descent means we're going to only change per sample, we change the weights once. So, and then for the mini batch descent, we're going to change from, we're going to take a group of data, we change for that group. And okay, so there's different advantages, there's advantages and disadvantages of each method. For example, with the mini batch gradient descent, you can see that they're going to be a lot of computation involved. Same thing as the stochastic. But the batch gradient descent, we only do it once, so it's less computation involved. Okay, so that's it about gradient descent. And then we spoke about different hyperparameters and parameters. And yesterday when we started, I said parameters are every settings that we're going to have, which are going to be automatically learned by the model. An example of a parameter is what we just spoke about, the weight. So the weight is learned by the model. The model will keep changing this weight in order for us to get our result. Okay. So, now these weights are going to be changed by the model. The fact that we don't control these settings, this is considered to be a parameter. But everything else that we can set manually will be called an hyperparameter. Like when we do deep learning, you're going to learn in deep learning, we have a process what we call a neural network. A neural network will be something like this. Okay, so in this case, for example, we will look at an example where we spoke about the age. In the example we spoke yesterday, where we're trying to see if a person can be a good athlete. So we look at the height, the age, and what was the third thing we used? The height, the age, and the weight. So we have that as our input. So this is the input layer. So we have the weight, the height, and the age. Now we see how this weight play a role. So each node in the first layer, which is the input layer, and this here is the output layer. Which will have two. In our case, we have a yes and a no, if this person is going to be an athlete. So now these features that we have here, now we create this is what we call, that's why we're going to talk about deep learning. This layers of node. These inside layers here will be there's another developer that will choose 2, another will choose 3. You can use as many as you want depending on the scenario that you're working on and the work that you are doing. So this, because you as a developer, you set the numbers of layers. So the numbers of layers in a neural network will be an hyperparameter because it's set by you. Now, each node in the input layer will create a relationship with the second layer. So each node here create a relationship with that. So each one. So now we're going to apply each one here, going to apply what's the relationship between this feature here. How does this feature play into detecting if we're dealing with an athlete or not? So we have a weight with the first layer. Weights, weight 1, 2, weight 3. And then the second feature as well, 1, 2, 3. So we have all these weights here. So this, whatever information we have, this multiplied by the weights that we have here will give us the value. So now these weights here are assigned by the model itself when the model is training. So maybe the first time, remember these features will be transformed into values. So the first time, maybe it's multiplied by a certain value, it gives us the value here, multiply by another one, give us the value here, give us the value here, and then this one as well go to the next layer. Here as well, there's weights applied to all these connections. So those weights are being changed. That's how the training process happens. Until we get to a point where it learns from all the data that we've done. And then it can be able to determine if the person is really an athlete or not. That's how the learning process happens in a neural network. Now, with the gradient descent method, it means that if you tell your machine to use the batch gradient descent, what you are doing is you are telling the machine, when you change the weight, you must change the weights of all the weights in the network at the same time. So if you choose to use mini batch gradient descent, what you are telling the machine is it must only change the weight for certain group of data, see how it's performing, and then change for the other group. But if you take the stochastic, it means you're telling the machine change each weight at one weight at a time. Okay, so that's what it means. So any setting that we create, we set ourselves is a hyperparameter. Okay, so you must think of hyperparameter as settings that we use to control the training. Okay. Okay, so now, because we're gonna find out situations where someone else in this scenario will use 2 hidden layer, the layer inside, but someone else, we're all gonna have an input layer and an output layer. But in between, someone else will choose 2 layers. Another person will choose 5 layers, and then how do we know we are choosing the right numbers of layers? We are choosing the right numbers of node in every internal layer. Now that becomes a bit of a problem. So this is why we can't guess this number. This is why we have some methods that can help us get the right numbers. We have different methods that are used. You have the grid search to search the hyperparameters. You have the random search, and then you have the heuristic intelligent search, and then the Bayesian search. Okay, so these are the procedures for searching hyperparameter. So how is that going to happen? We're going to divide the data set into training set, validation set, and testing set. So we do a data splitting. And then we're now going to optimize the model parameters using the training set based on the model performance indicators. So now we're going to see how these parameters are working how they're performing, and then that's how we're going to see. So basically, what we're going to see, you're going to search for the model at parameters using the validation set based on the model performance indicators. And then you perform this step, you optimize the model for parameters using the training set. And then you search the model hyperparameters using the validation set. So we remember we've divided, we have a validation set, we have a training set. And remember the parameters here are going to be set by the model itself. So you let the model choose the parameters. Now you choose hyperparameters using this validation set based on the performance of this model. So different methods will come with different ways of doing it, but the whole point is to get what type of settings we need to get, what type of, how many, for example, in neural network, how many nodes we're going to have per layer. Okay. Now, the search method, we have the first one, which is the grid method. What will the grid method do? It's just going to attempt to search all possible hyperparameters combination to form an hyperparameter value grid. So it's going to look at whatever settings that you wanted to write. Let's say, for example, you have the numbers of nodes, numbers of layers, all those information, and then it have them as a grid to see how they're performing when they work together. Okay. So the grids, one thing you need to know, the grid search is expensive and time consuming. Okay. And then the second method will be the random search. Okay, so the random search is used especially when we have such large type of hyperparameters that we're looking for. So we can use the random search, and then the other method will be the cross validation. Remember, the cross validation will just be a method that we're going to use to validate the performance of a classifier. What is a classifier? A classifier is a model that has been used for classification purpose. So we're trying to detect if we have a true or false, we have a yes or no, if we have a scenario where we're trying to classify the data into certain groups or into getting an output from, let's say, you're trying to detect if the picture of a fruit is a mango or it's an orange or it's a banana. So when you look at that, this is a classification problem that we're dealing with. So try and see the performance of that model. Is your model perfect? How is your model perfect? We have a method called cross validation. Okay. Okay, so these are the cross validation will work. We're going to look at the entire data set. We're going to divide it into training set and test set. And then we're going to try and compare the result we're getting with training data and the result we're getting with testing data. Or we can divide it into training set, validation set, and testing set. So now, here now, we depending on how we're going to do this cross-validation. So here, what we need to do is that we need to divide the raw data into K groups. K groups means depending on how many groups we want ourselves. So we can choose to divide into 5 groups. We can choose to divide it into 10 groups, depending on how big our data are. So each group that we're going to divide, each subset, we're going to use it maybe as a validation set. So let's say you have 10,000 data samples in your data set. So you're going to take maybe the first 2,000. So you divide it into 5 groups. 2,000, 2,000, 2,000, and 2,000. So you take the first 2,000, which you're going to train the model with the 2,000. You obtain a certain model. Maybe you call it model 1. Model 1. Now, to test if model 1 is performing well, you're going to use the second group of data as the validation set. So this second group of data is going to confirm if this model 1 is performing well. So now the numbers of K, that means the numbers of group of data that you're going to create, will be set by you. That's why we're going to say the K value in a K-fold cross-validation is also an hyperparameter. Why is it the hyperparameter? Because you are the one that is setting it, not the machine itself. Okay, so those are certain methods that are used to just try and deal with parameters and hyperparameters. Now, here comes the most important part, the common machine learning algorithm. 4 elements of AI: scenario, computing power, algorithm, and data. So now here is the part of algorithm. Remember, guys, the first question that we ask ourselves: what problem are we solving? Is it a classification problem? Is it a regression problem? Is it a, a clustering problem? Okay, so now here's how we're going to deal with it. So let me give you a scenario. We have an area. So we are looking for the prices. We want to rent apartments in a certain area. Okay, so the data that we were given, we were given data of the sizes of the apartment and the area where the apartment is. Okay, so we have the size and the area. The area means the place where the apartment is. Okay, so now let's look at that now. So looking at the size, so here is what we have. So we have the neighborhood or area that we have the, oh, what am I doing? So we have the area where we have the house, and then we have the size. Okay. So the size, so we have maybe here, the first one, we have maybe 100 meters squared, this apartment. This is in Santon. Second one, we have it in maybe Morningside, which is about 50 meters squared, right? So now, what we were given as, we now, what we're trying to do, we want to see the area, the size of the whole apartment, and then we can predict what should be the price for the rental in this area. Okay, so we were now given data. We were given about 100 houses, 100 apartments. So you have the first one, maybe 6,500. You have the second one, 7,000. And then you have up to apartment number 100, which is found maybe in somewhere maybe in Kempton Park. And then the size is 150, and then that costs you about 8,000. Okay, so when we look at this now, first question we need to ask ourselves, what scenario do we have? We have a scenario when we're trying to predict the prices of apartments based on the area where the apartment is and the size of the apartment. So now we want to create this AI tool that will do that. That will be used by real estate agents or agencies that are renting houses. What they're going to do whenever they get a new apartment, which area, what's the size, and the AI will tell them what price they should give the client. So the first question you ask yourself, what problem are we solving? Okay, so guys, what problem are we solving here? We were given the data. We were given the scenario. Now we need to create the algorithm. What problem are we solving? Anybody? What problem are we solving?
Regression.
Okay, you saying regression. Anybody else? Anybody else believe we solving another problem?
Classification.
Classification. Okay, anybody else? Anybody else? So what problem are we solving with this algorithm? Now that we want to create this AI tool, what problem are we solving? Before we know what algorithm we're going to use, what problem are we solving? Okay, so I can hear classification and regression. Okay, we're gonna start with classification. Why do you think it's a classification problem?
Because we classify them of determining the place and the space of the house, then we determine the price.
Okay. Anybody agree with him or disagree? Is there anyone who disagree with him? Is there anyone who says this is not a classification problem that we're solving? Guys, I want everyone to get involved so we all understand it. Is there anyone who think this is not a classification problem that we're solving?
I think it's regression because we are predicting the price, which is the number.
Anyone agree with Sam Kelo? Anyone is thinking like Sam Kelo that this is a regression problem? Guys, what do you think? Who's choosing classification? Who's choosing regression? Some Kelo said this is a regression problem. Anybody agree with her? So if you guys don't agree with her, it means that you disagree with her. So let's see. Entley, why do you disagree with Sam Kelo? Why do you think Sam Kelo is wrong? Is Entley present? Is she in the class or she's absent? Just joined the class, but she's not actually here. Let's check for someone else. Jemima. Are you in the class or you also absent?
Can I ask, can you please repeat the scenario then a bit for us?
Okay, we're trying to create an AI tool to determine the prices of houses or apartments based on the area where the apartment is, which means the neighborhood where the apartment is, and the size. So we were given data. We were given previous data of houses. We were given the areas, the sizes of each house, and what was the price. Those were the data that were given to us, about 100 data. So now we want to use those data to teach our machine to predict the price of apartment based on these features, the area and the size. So now that if this AI is done, the real estate agent will use this AI. Every time the house that come, they're just going to type which area, which neighborhood it is, and they type the size, it's going to automatically give them the price because the AI could have learned from our data. So now that we're trying to create this AI tool, what problem are we solving? Remember, we have three types of problems. We have a classification problem, we have a regression problem, and then we have a clustering problem. So here we ask what problem we're solving. There is two people who said it's a classification or regression. So now here, the first person say it was a classification problem. They explained themselves. And then some Kelo said it's not a classification, it's a regression problem. So my question here is there anyone who disagrees with some Kelo? Anyone who agree with her? Nobody agreed with her. So that means everybody disagree with her. So that's why I'm asking, Jemima, why you don't believe this is a regression problem?
So I think it's clustering because one of the keywords you said was that we give the AI the data to learn. So that means it's unsupervised learning. And also, I think with clustering, because I think clustering is like where it organizes it in pieces or something. So it will organize it based on those attributes of size, area, location, and so on. So I think it's clustering.
Okay, guys, anybody else? Guys, there's no right or wrong answer because every time there is someone who open the mic and say something, they say something that can benefit the other person and can benefit the whole class. This is very important because once we understand what's happening on this page, the rest of this course is going to be easy. If anyone does not understand this page, everything else is just going to be magic for you because everything that is done in AI is done based on this page. Every AI tool that you've seen, from ChatGPT to Gemini to Siri to everything, you have to answer the question, and everything is on this page. So this is very important. So we have a classification, regression, and clustering. Three people explain themselves why they think it's one of the three. Okay, so now we Entle, you still not in the class? Oh my God, there is difficult names. I don't know. The people with difficult name are saved for today. I'm gonna learn how to pronounce these names. Let's see. Nonfundo, what do you think? Give us a guess. What do you think? What type of problem is it?
I'm stuck between the two, right? Which is the classification and the regression, because it is, I feel like the model, right, is currently supervised by using like an existing model that was previously trained. So I'm just stuck between the two. I'm not sure which is which.
Okay, thank you for your feedback. As well, when Nonfundo spoke, I saw also another misunderstanding. So when everybody is speaking, I'm discovering some misunderstanding, and that is very important. Very, very important. I'm happy I'm asking everyone to talk is very important. And another thing is they've asked me to make sure, because remember your cameras are off. Some people, they just join the class and then they don't really attend the class. And one thing I would tell you is they don't officially tell you that, but I'm going to tell you that they usually because when you attend the class like this, we have a report. That's why we take an attendance screenshots, because they usually think of what they can do for the people or the person who has been attending the most. So there have been a lot of classes where they will ask me to actually submit the information of the person who has been the most active in class, and they will ship you some gifts. I think the last class I had, there was someone who got a tablet, another one got a phone. Guys, it's very important to be active in class, because this is all about learning, and you can't learn if you keep quiet, because we don't know what are your challenges. Okay, guys. We need to enjoy the class, guys. Today is my birthday. I should be hitting somewhere or having some dinner somewhere, but I'm here in class, so it's good if we enjoy the class. All right, so okay, so I'm gonna go back to who was the first person who said? I'm trying to see what was the name of the first person who said it was a classification problem. Please remind me again, who was that?
It's me, sir.
Okay. How do you pronounce your name? Matley, right? Mathieu. Okay, Mathieu. Okay. So, all right. So the person who's right amongst all the people is, I think, Samkelo, who said this was a regression problem. So, Mathieu, this is not a classification problem. Why? How do you see the problem? You need to ask yourself what problem you are solving. So what problem you are solving takes you to what are you predicting? So what are we predicting here? We are predicting the price. How is the nature of the data that we are predicting? The price can be any value. It can be 5,000, 5,652, 5,000. It can be any value. So we don't know what will be the output. It can be any number. Because the output is discrete, because the output can be any value, that means we are dealing with a regression problem. Classification is only, you see, there's a word class. Classification is when you are dealing, your output needs to be only a certain group of data. So in this case, if we want our system to only give us to choose between 5,000, 6,000, and 8,000. We have a class of 3. We have 3 classes. In this was going to be a classification problem. But because we are choosing, it's going to give us any type of answer, any value. That's why this is a regression problem that we are solving. For, who was that? I think Jemima who said clustering. Clustering problem is the data will not be classified. We're not going to get any output, but we're going to create this data to output certain classes. Not like here where we have like certain classes, no, but we're going to group the data based on the similarities of data. That is clustering, but we're going to give more details. You're going to understand more the difference between clustering and classification. And you mentioned, you say it's unsupervised learning. No, it's not unsupervised, because we already give the label. We are trying to predict the price. And with the data that we receive, we already have the data, the output, which are the prices. So we already told the model, this is the prices for the data that we have. So this type of learning is supervised. It is supervised. The prices are not being created, but the prices are based on the data that we created when we were training the model. So now that we've determined what type of problem we are solving, this is a regression problem. So we know we're dealing with a supervised learning. In a supervised learning, the type of algorithm we have, problem we're solving, regression. It means we're gonna use one of the algorithm in regression. This is why we're going to study all these algorithms and see in what cases do we use which algorithm. As you can see, certain algorithms solve regression problem and they also solve classification. You can see. There is many regression algorithm that can also solve classification problem. Okay, so now in this case, we're going to see now we've agreed that we're solving a regression problem. Now you can see which algorithm we're going to use. You understand, guys? So if you cannot answer the question, what problem you are solving, you're going to use the wrong algorithm. Okay, so now look at the first algorithm we're going to talk about is linear regression, which is used for what problem? For a regression problem. So because now we have that, we're going to look at the regression problem. How does the regression algorithm work? We need to understand the linear regression, which is an algorithm used for regression problem. This is just a method to determine the quantitative relationship between two or more variables through regression analysis in mathematics. So what does it mean? These are our data. In our cases, these are our data, and then the regression from is now the AI is going to learn from all these data and create this. This is our model. Or sometimes the model is going to be thus represented as a plane. So the model can be in a regression problem, they can be represented as a line or a plane. So this is a linear regression. Why is it called linear regression? It's represented by a line. So those who have done mathematics, what is the equation of a line? Y equal AX plus B. Remember that. So the linear regression, this is what we have. The equation, same as I told you, AX plus B. Now in this case, what will be the A, the value here? These are the weights that the machine is going to be learning and changing. And this B is a bias, which is another value that we can add there. It's usually something like 1, another value just to try and fix the equation. So now, in this case, in the linear regression, so the sample, here we're dealing with sample, the X represent the sample. So we have the first sample where we're going to get the equation. We have the second sample, and then until we get the values there. So now, here, normally there's going to be an error. So the relationship between the value predicted by the model and the actual value will be the error that we have. So can you see here? So this is what the model is predicting. But the actual value of what we're trying to predict will be something like this, plus an error, because there's an error that will be there. We can't predict it at 100%. So there is many factors that will influence the error. Okay, so now that error is what we call a loss. Now, what we're gonna do, we need to create what we call a loss function. So in the linear, if you use the linear regression algorithm, the loss function is represented by this formula. So now to reduce the loss, that's where we have to apply those gradient descents that we spoke about, where we keep changing the settings, the machine keep changing its settings itself and reduce the loss so that in the end we have something. Because think about it, guys, if this error is equal to, remember, this is what our model is supposed to be. And this is what we're getting. We're getting the model that we're supposed to have plus the error. Now, the question is, if the error is reduced to 0, what will happen? Our system is giving us exactly what we're looking for. Okay, so linear regression can be also extended to what we call polynomial regression, depending on how our data are represented. Okay, so now, remember, this is the loss function that we have. And now to avoid an overfitting problem, remember, guys, we spoke about the problem we can have. Overfitting means that you have so much data. Your AI has been so, you've worked on it a lot, it's sophisticated, but the amount of data that you have is not really fitting your algorithm. Okay, so now we need to make sure that all the weights that we are using to avoid that the loss function lose it, we need to create what we call certain regularization terms. So this is a regularization term for us to be able to regulate how we want the weights to change. So remember, I told you in this example here, I gave you the example of the neural network where we're trying to change different weights. But now we need to regulate that, or else the machine is just going to be changing. You see here, this weight here, this weight. We need to regulate it because we need to tell the machine, limit yourself to certain numbers. Don't just choose any values and lose it. So those are what we call regularization, or we can also call them the L norms. We have the L1 norm and the L2 norm. So these are regularization. So this here is where we regulate the weights that needs to change. So to regulate, we have two norms. We have the L1 and the L2 norm. Okay. So now in linear regression, the regularization norm that we're going to use to regulate everything, we're going to use what we call the ridge regression, which is the loss function that is used. Now, in a linear regression with absolute loss, we call it a lasso regression. Okay. Okay, so that linear regression. So linear regression, remember, we are dealing with problem of regression, and we actually represented that function as a line. But next week, as we go through it, we're going to take the example that we spoke about it today. Then we're going to see every step of training the model, how it works, and you'll understand. And remember something, guys, these formulas, you don't need to memorize them, but when you are actually coding, these formulas are represented by a simple word. In your code, you just say linear regression. Okay. I'm just going to see if I can the one linear regression. I wanna show you when you look at it in Python, for example, it comes as a simple simple code, which is it's just a word. You're not gonna have to actually write the whole formula or everything like that. Okay, so let me see that if I can see it. Okay, no, it's fine. I'm not finding it. All right, guys. So next week we're going to talk about other algorithms such as logistic regression. But one thing very important to note, especially when it comes to logistic regression, despite the fact that you can see the word regression, logistic regression does not solve a regression problem, but it solves a classification problem. You can see in this case, we're trying to determine between 1 and 0. This can be solving a classification problem where we have a true or false, where we have a yes or no. Okay, so that's logistic regression. So this is an example of when logistic regression can be used to determine between male and female, or to determine this is a binary classification, only two choices. But when you have multiple choices, you have a multi-class classification problem. Very important. Okay, guys. So logistic regression, it's just an algorithm that you're going to use whenever you have a binary classification problem, which means where you just want to choose between two. You only have two choices. Which algorithm you use a logistic regression. So this is an algorithm used when you're solving a binary classification. But if you're solving a multi-class classification, you don't use the logistic regression, but you use the softmax function. We're going to talk more about it next week. All right, guys. This will be all for today. And I guess is there any question? Any question, guys? Any question? Any question? Guys, in the meantime, you can just turn on your cameras, and then we can take it from there. So, guys, remember, this is very important. Before we start next week, we're gonna talk more again about this. Remember, when we talk about logistic regression, it does not solve a regression problem; it solves a classification problem. But when we talk about linear regression, we're talking about solving a regression problem. I've given you the example here. So I hope that you guys understand. But I think next week we're gonna take it a bit further. We're gonna have some exercises. Okay. All right. So this is just the equation that is used to reduce the loss function. So to reduce the loss function, to reduce the loss in when we're training our AI. All right, guys. All right, so I've taken the speech of the attendance. So I will see you on Tuesday. Have a great weekend. Goodbye.